This video contains the solution for number 5 from the AP Calculus 2010 BC test. It's another differential equation problem. So let's see what we have. Consider the differential equation dy dx equals 1 minus y. And y equals f of x is the particular solution with the initial condition goes through the point 1, 0. For this particular solution, f of x is less than 1 for all values of x. Alright, see how that comes into play. Using Euler's method starting at x equals 1 with 2 steps of equal size, we want to approximate f of 0. So let's see if we can do that. 5a. Euler's method, we need to know x value, y value, dy dx value, and then we'll multiply that dy dx times delta x. That'll give us the delta y that we come back and add to the y value, right? Because those effectively cancel out. So let's see, what are our values here? We're starting at the value 1, 0, and in 2 steps we want to approximate f of 0. So we're actually going down here, so we go from 1 to 0.5 to 0. That means my delta x is negative 0.5. Be careful, it's a negative change in x. Now, dy dx is 1 minus y. The y value here is 0, so 1 minus 0 is 1. When I multiply that times the delta x, that gives me negative 0.5. So that's the change in y. Bring that back to here, add it to the y value. So I have negative 0.5 here. Now, dy dx is 1 minus y. So 1 minus negative a half is 3/2, or 1.5. Multiplying that by negative 0.5 gives me negative 0.75. And then when I bring that back and add that here, that's negative 1.25. And that is my target y value. So f of 0 is approximately equal to negative 1.25. They say show the work that leads to your answer. Well, there it is. It's the table. So they do expect us to do, this is no calculator. You did have to do all that without a calculator, but that wasn't too bad. Part B, find the limit as x approaches 1 of f of x, which is the particular solution here, over x cubed minus 1. Well, how would we do that? If you're thinking limits on the BC test usually involve L'Hopital's rule, then I think you've got a good idea here. So let's see. First of all, let's see if this is a 0 over 0. When I plug 1 into this, I get 0. And when I plug 1 into this, it is in fact a 0 over 0. So that means L'Hopital's rule says I can take the derivative of the top, which is 1 minus y, over the derivative of the bottom is 3x squared. And the weird thing about this is there's a y in here, but we know that when x equals 1, y equals 0. So plugging in a 1 for an x is equivalent here to plugging in a 0 for a y, because x being 1 goes with y being 0. So 1 minus 0 over 3 times 1 squared is equal to 1/3. So we use L'Hopital's rule in a kind of a novel way. And you can expect to see some little twists like that on the AP test. And last, they want us to actually solve the differential equation. So the differential equation is dy dx is equal to 1 minus y. So separate variables. That gives me 1 over 1 minus y dy is equal to dx, or 1 dx if you want. Integrate both sides. That gives me negative natural log of 1 minus y. Again, the negative sign comes from in here. You can write out the u substitution, but it's a pretty simple one. Equal to, the antiderivative of 1 is x plus c. Let's see, I'm going to move the negative to the other side. natural log 1 minus y is equal to minus x. The c can absorb the negative. We'll worry about that later. And then exponentiating both sides. That gives me 1 minus y is equal to e to the negative x plus c, but that c can move down because x squared times x cubed is equal to x to the fifth, 2 plus 3. So when I have things like this, I could use that rule backwards. So that's like e to the negative x times e to the c, and e to the c is just some other constant, some other version of c. And then almost there, solving for y, y equals 1 minus c e to the minus x. And my initial point is the point 1, 0. So plugging that information in, I get 0 is equal to 1 minus c e to the negative 1. So let's see. That means that c e to the negative 1 is equal to 1. So divide that over. So it looks like c would be equal to 1 over e to the negative 1, or in other words, c is equal to e. So plugging that back in here means I have y equals minus, if I multiply e times e to the minus x, you could leave it as that, but for the same reason as what we just did here, e to the 1 times e to the minus x, that's like adding one more e into the exponent. So that would be e to the minus x plus 1. You could leave it as e times that if you didn't want to simplify, but that's probably the nicest version of the answer, in my opinion.